The write side was about protecting the truth. The read side is about handing it out, and it's a different job with a different failure. Reads don't change anything, so they're safe, right? Mostly. But there's one line of code that looks completely innocent and takes services down at scale, the endpoint that returns a list. Get all the overdue orders. Get this customer's orders. Written the obvious way, that's a time bomb. Let's read the right way. First, reads are their own thing. A query loads data and projects it. It never changes state, and it never hands your domain aggregate straight to the client. Instead, it maps to a response DTO, a type you own that's shaped for the wire. You decide what to expose and what to keep internal, so tomorrow's refactor of the aggregate doesn't break every consumer. And here's a nice reuse from the right side. A read returns an ETag, the same version token that guards concurrency, which means a client that already has version 7 can send it back and ask, still 7? And if nothing changed, the server answers 304, not modified, with no body at all. The cheapest response is the one you don't send. Now the trap. You write get all overdue orders. It returns an array, the tests pass, you ship it. In development, with a handful of rows, it's perfect. Then the data grows, and one day that endpoint loads every overdue order into memory, serializes a payload measured in megabytes, and the request times out, taking a chunk of your database and your service with it. A list endpoint with no upper bound isn't a feature that scales poorly. It's a defect that hasn't met production yet. The rule is simple and absolute. A list endpoint returns a bounded page, always. The only question is how you let the client walk through the rest. The naive answer is offset. Page 2 is skip 20, take 20. Don't. Offset makes the database rescan and throw away every row it skips, so deep pages get slower and slower. And if someone inserts a row while you're paging, everything shifts and you get duplicates or gaps. The robust answer is cursor pagination, sometimes called keyset. You order by a stable, unique key. Here, the order's ID, which is a time-ordered UID, and the cursor is just the last key you saw. The next page is give me the rows after this key, which the database answers with an index seek instantly, at any depth. You cap the page size so no single request can ask for too much, and you hand back a nextCursor. The client walks forward one bounded page at a time, and it's correct even as data changes underneath it. Here's a read in full. Send the query, and map the result with orderResponse.from. That's the projection, domain aggregate to a wire DTO the controller owns. Then two options on the way out. With ETag emits the order's strong version token, and evaluate preconditions turns on conditional reads. If the client sent if none match with a token that still matches, the framework returns 304, not modified, and skips the body entirely. So the same ETag we use to reject a stale write now saves bandwidth on an unchanged read. One version token, two jobs, correctness on writes, efficiency on reads. And here's a list that can't run away. The query itself is bounded by construction. It returns a page of order, and it only accepts a cursor and a limit. The handler clamps that limit to a maximum with page size.from requested, so a client can't ask for 1,000,000 rows, and it decodes the cursor if there is one. Then the repository does the seek. To page async orders by the unique ID, applies the cursor as a rows after this key filter, overfetches by 1 to know whether a next page exists, and returns the page plus a nextCursor. There's no offset, no full scan, and no way to accidentally load the whole table. Bounded reads aren't an optimization you add later. Here, they're the only shape the query can take. So the read side has its own discipline. Project to DTOs so the wire shape is yours, not your domain's. Reuse the ETag to make reads conditional and cheap. And never, ever return an unbounded list. Bound every page with a cursor and a capped size. So the endpoint that's fine today is still fine at 10 million rows. We can now write safely and read safely. Next, the question that decides who's even allowed to. Authorization, permissions, roles, and ownership. Subscribe, and I'll see you in episode 5.